Okay guys, so in this section we are looking at what's called imaginary numbers. That's going to be the big topic. Imaginary numbers, we use this letter I. It's always in italics. So we will be looking at what that means. We're also going to be able to perform operations with complex numbers. That means add, subtract, multiply, divide. And we want to be able to find complex solutions in zeros. The imaginary unit I is defined as this. The square root of -1 is I. That's what we call it. The reason imaginary numbers started is because people were solving equations. When mathematicians would solve equations, they would get these numbers like x squared equals -9, and there would be no real solution. So since there was no real solution, they're like, hey, let's come up with a different kind of solution, imaginary. And so that's why we have this definition of square root of -1 is I. We can also have what's called a complex number, a plus bi. A is going to be the real part. So it could be like this. It could be like 2 plus 3i. 2 is the real part. This would be the imaginary part. When we have imaginary numbers, as long as b is not equal to 0, we can also call a plus bi an imaginary number. A pure imaginary number is when we just have a plus bi, but a is equal to 0. So that would be like 4i. We call that pure imaginary. 7i is pure imaginary. But if I have 2 plus 3i, that is just imaginary. It's not a pure imaginary. All right, square root of a negative number. This is going to be if we have the square root of -3. Whenever I have a negative under the radical, I get rid of that negative under the radical by putting an I on the outside. Because what this really is the square root of -1 times the square root of 3. The square root of -1 is I. On this one, if I have I radical 3 and I want to square it, I squared, and then radical 3 squared. Radical 3 squared is 3. I squared is just going to be -1. Think back up here, you guys. If the square root of -1 is I, if I square this and I square this, that's going to tell me what I squared is. Does that make sense that I squared would be -1? If I square this side, I get I squared. If I square this side, the radical goes away and I get -1. So that's a very important thing to know. Alright, so let's look at this problem right here. It says simplify the square root of -9. So if we're going to simplify that, I'm going to think of this as the square root of -1 times the square root of 9. What's the square root of -1? I. What's the square root of 9? 3. So what's this answer going to be? 3i. Good. That's going to be 3i. Alright, let's look at this one. So now we have a number in front of here. So we've got 3 times, I can break this up into the square root of -1 times the square root of 25. So now I've got 3, this would be I, and then this would be 5. And so what would you think that's going to be then? 15i is the answer. Now, we're going to have a pattern for I. This pattern is going to go like this. The square root of -1 is I. What did we just say I squared is? -1. I to the third is going to be I squared times I. Well, I squared we said is -1. So -1 times I is -I. So we need to know that I to the third is -I. I to the fourth would be I squared times I squared. What do you think I to the fourth is going to be then? 1, good. I to the fifth. Well, I to the fifth is going to be I to the fourth times I. What did we just say I to the fourth is? So this would be 1 times I, so what's I to the fifth? I. And then I to the sixth I to the 6th would be I to the 4th times I squared. I to the 4th we said is 1. What did we say I squared is? So what's I to the 6th going to be? What do you think this pattern is? I, negative 1, negative I, 1. I, negative 1. What do you think I to the 7th is? Nope, not 1. Negative I, right. And then what about I to the 8th? What do you think it's going to be? 1. Can you tell me the next time we would get an answer that's 1? Would it be I to the 9th, 10th, 11th, or 12th? I to the 12th, right? I to the 12th would also be 1. When would be the next time? I to the 16th would be 1. So what if I then asked you what's I to the 17th? Well, if I know I to the 16th is 1, what do you think I to the 17th would simplify to? I, good. All right, just looking at patterns there. One more. What would you think I to the 102nd would be? I'll throw a Kit Kat to whoever can tell me first. What do you think? What did you say, Allie? Negative 1 is right.
I wish I could remember my notes.
Oh, this is going to be a long throw. Oh, okay.
I'm just assuming that I was going to process for when I was and it bounced everywhere.
All right. Okay, guys. Adding and subtracting complex numbers. This is going to be just exactly the way you think it would go. If I'm adding complex numbers, all I'm doing is I'm adding like terms. So I've got a negative 3, that's my real part, plus 2, that's going to be negative 1. Then we have 4i plus negative 3i, that's going to be plus I. That's all we have to do, add like terms. I want to show you something cool on our calculator. Our calculator knows what I is. I can type in negative 3 plus 4. Right here's the I key. Can you see it above the decimal? So watch. I'm going to push second decimal. Look what I have. 3 plus 4i. Plus, you don't need to do this, just watch. Parentheses, 2 minus 3i. So I'm going to add those two. Again, the I button's right here above the decimal. And then I push enter, and it tells me the answer, negative 1 plus I. Pretty nice, huh? Okay. Yeah.
Can you show how you got that without the calculator?
Yeah, sure. So without the calculator, what I did is I'm looking at the real parts, and I'm looking at the imaginary parts. So I'm doing negative 3 plus 2 is negative 1. And then I'm doing 4i plus negative 3i is positive 1i. Okay? If we're subtracting, I may want to write this out. I've got negative 3 plus 4i minus 2 plus 3i. Why did I put plus 3i? Distributed the negative. Most people forget to do that. I have to do negative times this, negative times that. So this answer is going to be negative 5 plus 7i. I could check it on the calculator, but we really don't need to. All right, number 3. We've added, we've subtracted. Here we are multiplying. If I'm multiplying two things, I have to FOIL. I'm going to have to do the first times the first. That's negative 6. I have to do the outers. That gives me positive 9i. I have to do the inners. That gives us positive 8i. And we have to do the last. So what's positive 4i times negative 3i? Negative 12i squared. Good. So we would have negative 12i squared there. So now I've got negative 6. These two added would be 17i. What did we say I squared is? So what's negative 12 times negative 1? positive 12. And so now I'm going to keep combining like terms. Negative 6 plus 12 is 6 plus 17i. Any questions on how I got that? All right, let's come down here now. Let's do these kind of quickly. You should know what this is. What is it, guys? 7i. Anytime we have a negative under the radical, it's I. Square root of 49 is 7. What's the next one going to be? 2i. This one I'm going to have to think of as the square root of negative 1 times the square root of 9 times the square root of 5. The square root of 9 is 3. The square root of negative 1 is I. The square root of 5 I can't do. This is the order we want to write it in. We want to have the real number part, then the imaginary factor, and then that radical. Okay? It looks weird because I didn't do it in the order that it came, but we always want that whole number first, then the I, then the radical. Alright, let's try this one now. We have negative 2 times, what's this going to be? What is it? 10i, right? So then this is going to be negative 20i. Anybody know what this one's going to be? Can you think ahead? $66i, I heard. Do we agree? 66i, or is it negative 66i? It's 66i, isn't it? This is 6 times the square root of negative 1 times the square root of 121. This is 6, this is I, this is 11, that's 66i. Alright, on this one, 5 times square root of negative 1 times square root of 25 times square root of 3. All I'm doing is I'm breaking this apart into parts that I can actually evaluate. See, I know the square root of 25, so I wanted to use that because I can take that square root. So now I've got 5 times I times 5 times radical 3. You guys know what it would be? Yep. Perfect. Okay. The next one. In exercises 7 and 8, find the values of x and y that satisfy the equation. This is just seeing if we understand the real part and the imaginary part. This is the real part, this is the real part. So I would set negative 10x equal to 30. So dividing by negative 10, x is going to be negative 3. This is an imaginary part, and this is an imaginary part. So setting 1i, that's 1i, equal to negative yi, I want to know what y is, so how do I get y by itself? Divide by negative I. So now these would all cancel and I would just have y. What's I divided by negative I? Anything divided by itself is just 1, so what's it going to be? Negative 1. The next one would go the same way. Look at your real part. Set those two equal to each other. Look at your real part. I'm sorry, I said that backwards. Look at your real part. Now look at your imaginary part. So how would I get x by itself? Multiply by negative 4. If I multiply that by negative 4, what is that? Negative 176, I believe? What would I do here? I could multiply both sides by negative 2 first, and I'm going to now have yi equals negative or positive 14i. I really don't have to do anything else, do I? Can't you tell what y is right now? If I have yi equals 14i, what is it? Y's got to be 14. couple more. This is just reviewing what we did. So I'm not going to do this one, except to say whether it's a pure imaginary. Let's go ahead and do this one. What is 16 plus negative 16? What's I plus negative 8i? Negative 7i. Is that a pure imaginary? Does it just have an imaginary part? Yep, so it's pure. Pure means it just has imaginary, no real parts. On the next one, I'd have negative 5 minus 5i plus 6 plus 6i. That's going to be 1 plus I. Is that a pure imaginary? Nope, just a regular old imaginary. Okay, and then we're going to do one more with multiplication. Let's go ahead and do 11. So I have to multiply this times this is negative 15. This times this is positive I. That's going to be 90 and 45. That's 135. That's going to be negative 9i squared. What is I squared again? Negative 1 times negative 9 is going to be plus 9 is what that really is. So now if I have negative 15 plus 9, that's negative 6 plus 136i. If I wasn't sure I did that right, I could put it into my calculator and check it. We won't take the time to do that, but we could. All right, this chart right here, you're going to need this, guys, to be able to do some problems later, so you're going to have to look back at it when you go to do the Big Ideas assignment. Here's what it's looking like. We have all these different parts to this series circuit. We've got this little dash thing, You can see that that's going to be the R value. It's called the resistance. We've got this double thing here. This is going to be called the capacitor, and it's always equal to negative CI. So this part right here is always going to be equal to negative 14I. Just looking at that chart, it tells me it's whatever C is, but it has to be negative and you have to put an I after it. This one right here, this little jaggedy thing, that's the resistance. That's always just the same as R. So what would I put right here? Just what? Just 5, right? Because it's just R is what this side is. That's its impedance is what it's called. Now this side has the little squigglies. That side is called the inductor side. This side is equal to whatever that number is, but you have to put an I after it. So what am I going to put right here? 10I. And so now to find the impedance of this series circuit, I'm trying to find this value right here. So all I have to do is just add all these together, and that tells me what the impedance is of that circuit. So what would I get if I combine them all? Right, 5 minus 4I, that would be that impedance of the series circuit. And so that's something that they always tell you, oh, use imaginary numbers in electronics. That's the example where it's used, is on these series circuits that they use in electronics. Okay? Any questions? What's I again? Square root of? What's I squared? What's I cubed? Negative I. What's I to the fourth? 1. I to the fourth is 1. All right.